Hello everyone, myself Manisha. In this experiment, I am demonstrating interfacing of an 8x8 LED matrix with the 8085 microprocessor using the 8255 programmable peripheral interface. First, see how LED matrix works. An LED matrix consists of 64 LEDs arranged in 8 rows and 8 columns. Instead of connecting each LED separately, they are arranged in matrix form to reduce the number of required input-output lines. In this module, the anodes of the LEDs are connected to the rows and the cathodes are connected to the columns. An LED glows when its corresponding row is at logic 1 and its column is at logic 0. By selecting a particular row and column combination, we can glow a specific LED. Since we can't turn on all LEDs simultaneously due to limited input-output lines, we use a technique called multiplexing. In software multiplexing, rows are activated one by one at high speed while corresponding column data is applied. Because the switching is very fast due to persistence of vision, the human eye perceives it as a continuous character. In this experiment, we display characters A, B, and C sequentially on the LED matrix. I will explain the 8085 program used to display characters on the LED matrix. The program starts at the address 2000. At address 2000, MBI A80 loads 80 into the accumulator. Out 03 send it to port 03. This configures all ports of 8255 as output ports. At address 2004, MBI D03 loads the counter value for 3 characters A, B, and C. Next, LXI H2050 loads the starting address of the character data into the HL register pair. This address contains the pattern data for displaying characters A. The program then uses multiple nested loops. Register C is loaded with 08 because each character required 8 bytes of data, 1 data for each row. Port A drives the row. The instruction MOV AMM loads row data from memory and out 00 send it to port A. Port B drives the column. The instruction move AB followed by out 01 sends rotating 0 patterns to the columns. The instruction RLC rotate the column bit to select the next column. This creates scanning of columns. A delay loop is included to maintain visibility of each LED rows. After displaying all 8 rows of one character, the pointer moves to next character data by adding 08 to the address. This process repeats for character A, B, and C. Finally, the jump instruction loops the program so the characters are displayed continuously. This is our hardware setup. Now we will enter all the commands in our LED matrix 8085 microprocessor. You can see LED matrix is displaying ABC in a loop, continuous loop. We can playing ABC. What innovative thing I have done? I tried to display my whole name in a continuous loop.